Hello, I'm Valdas Maksimovičius, and today I would like to share with you my observations about different data engineering patterns and principles. Where this idea for this talk? Basically, if you look up software development, then you will see many design patterns, different practices as domain-driven design, continuous integration, test-driven development, etc., etc. And for the software development, we have many great books that describe way of working. Mythical, Man-Month, Code Complete, great book about best practices, how to write great and maintainable code. Design Patterns, amazing book, quite old right now, but great book that put foundation for writing great object-oriented software. Then amazing book by Eric Evans on domain-driven design, test-driven development, or architectural patterns. But now, if I'm just think about all those books and all those patterns, and I come back to data projects, in data projects sometimes I have this feeling that it's a cowboy world. What does it mean? Not all the time you will have continuous integration and continuous deployment. Many data pipelines are not covered with tests. And what does it mean? It means that it's called cowboy coding, cowboy style. That sometimes even you deploy something to production without full test, and you are not sure how this feature might work in production. But you might say, oh, well, you are making huge fuss out of it. Maybe, but then I have another question to you. Look, there is a self-driving car, and would you be confident in sitting or even sitting in a driver's seat in that self-driving car? Well, let's make things even worse. What if you know that there is your software running that car? If you felt a bit uncomfortable, that means data pipelines or software that you are working on maybe might be a bit improved. And let's take a look at the definition of design pattern. The whole idea behind design patterns and principles is to standardize and increase that descriptive power. And in other words, we would like to stand on the shoulders of giants and this great software, great patterns that are already built, and we would like to reuse what already exists. Or even in other words, we would like to stop reinventing the wheel. So what are best practices for data engineers to build great data pipelines, to build great software? But first, why do we need those patterns? And here's an interesting thing that I found out about our brains and how our brain works. It's the left side of our brain is responsible for analytical thinking or logical thinking, and it stores those logical boxes as Legos. And interestingly, it uses those building blocks that you get over time to build and to model all surrounding world. What does it mean? Well, if you like relational databases or if you like tables, then you will try to model everything as table. And even though there are NoSQL databases and other type of databases, you will not use that because you are very proficient in table representation and you will try to use just tables. And in the context of design patterns, as architects, as software developers, you would like to expand your tool belt to learn new patterns and to learn new building blocks to solve business problems better and more efficiently. A bit about me. I'm Valdas Maksimovičius. I'm IT architect at Cognizant. I specialize in data engineering, data science, cloud computing, mainly building data lake and data science environments in Azure and GCP, and I'm working with agile teams. In terms of domains, I'm working mainly in financial, which is insurance, pensions, with manufacturing, logistics, a bit of retail industries, to mention the main ones. I'm an organizer of Vilnius Microsoft Data Platform Meetup and Hack for Vilnius Hackathon. In Hack for Vilnius Hackathon, we focus on open data, what data is available about the city of Vilnius to improve living and to improve the overall services that are available in Vilnius. And in my free time, I'm blogging on valdas.blog. When I speak about the whole agenda for this presentation, I was focusing on Maslow's hierarchy of needs. And if we think about this hierarchy of needs for people, first we think about biological and physiological needs. Then we have safety needs, love and belonging. We have esteem needs. We would like to be unique individuals. And then we have experience, purpose, and meaning, and self-actualization. To simplify this, basically, if a huge bear is chasing you, just means safety need, most probably you will not be thinking about writing a poem about that, which is self-actualization. And in a similar manner, we can look at that in data projects. What is Maslow's hierarchy of needs for data projects? And this is just my opinion, but we can look at what is the culture, what are core values, how teams are working with each other, what are business drivers, basically what are business objectives that we would like to solve with our data projects, what are data architecture principles, do we build or do we buy solutions, do we use cloud, etc. Then data strategy, are we defensive? That meaning we are not taking too many risks and we are not willing to expose our data to build machine learning models, for instance. Rather, we are conservative, or our risk appetite is a bit bigger and we would like to utilize data as much as possible. Then, what type of skill set we have inside our team? Do we have database experts? Do we have what type of programming languages our teams know? Things like that. And on top, we have the design patterns. What are different tools and what are best practices and principles working with these? This is my view of the hierarchy of needs for data projects. In the context of this presentation, I will simplify this a bit to look at the culture principles, at the data architecture principles, what are ingestion, storage, consumption, how data is collected, stored, transformed, basically what do we do with data, and on top what are different tools and principles working with that. This is the plan. Then let's start. First, culture. I think this is extremely important to define principles of how your teams and how your individuals are interacting with each other. And the great set of principles are coming from DevOps culture. And initially, this is coming from a great book called The Phoenix Project, and there are 7 principles. This one, we would like to foster collaborations within team, between individuals. People should be willing to discuss their problems with each other, solutions to help each other. Second is my favorite one, would like to impose end-to-end responsibility. What does it mean? That if you are building something, then you will be running it in production. That means that you will make sure that your software is as good as it could be, because otherwise you don't want to spend your holidays fixing your issues that maybe you forgot something during the development phase, which is a great principle to impose this end-to-end responsibility. Number 3 is we would like to encourage continuous improvement, meaning teams should always be looking how to learn something new and how to improve their software. Then number 4, we are heading and we would like to automate almost everything. It's in data world, it's not always possible to automate everything, but this is high level objective. Then we are focusing on the customer's needs. Or in other words, it doesn't matter if you are on time and you finished what you've been asked if no one needs that. So we would like to all the time focus on what customers need. Number 6, embrace failure. In other words, try what happens, what bad happens when shit hits the fan. What if your server goes down? So don't wait for those failures. Turn off that server and take a look how other components will work. And number 7, you have to unite teams. It's not only about interactions in your team, but it's about interactions in the whole organization, how your teams are knowing other teams and basically without your or architect or manager's responsibilities. And there are 3 great books that I truly encourage and I recommend reading. The first one is Lean Startup by Eric Rice. It's a great book about the concepts of building startup or just building great software and listening to your customers. The Phoenix Project and the Unicorn Project are coming from the same author. Those are a bit similar. The Phoenix Project focuses on the DevOps as such, and the Unicorn Project is the fresh book by Gene Kim, and it tells a story about the Data Hub team and the importance of efficient integrations and efficient teams. What happens if you are working beyond and above of your responsibilities? So highly recommend that. But now let's dive into another part of our presentation, which is data architecture and principles overarching that. First one, that especially people nowadays are heading towards cloud, and my tip is, if you are building a data platform in the cloud, you have to remember one thing, that this simplicity to start overshadows complexity. It's very easy to build initial solutions, but in long term, some of the steps might become almost impossible to achieve if compared to other open source software. So what I would like to focus that even though you are using cloud, don't forget that at the end of the day, that might be quite difficult to achieve or to implement all the requirements. What I would like to encourage is for you to look at big data cloud architecture references. Why I think this is important? Because there are many great solutions that we could reuse from different providers. And one example would be to look how Microsoft is suggesting solving big data problems. Another approach, Amazon. What are components and what are architectures that Amazon is suggesting for their cloud users? GCP. And those are just 3 examples, but make sure that, let's say, if you are using Azure, don't be bound to those boxes and that thinking just to Azure. Read a bit how others are solving the same problems, and you might find really unique and original ways and really elegant ways of solving your problems. But in the context of this presentation, let's take a look at the simplified slide. And we would like to start with ingestion. What are good practices and patterns for ingestion? So first of all, you need to remember that there are certain application integration approaches. The simplest one and the cheapest one is file transfer. Basically, systems are just sharing the files with each other. But it has some disadvantages that files are more for batch approach, and if you would like to have more real-time-ish integration, then file definitely will not work. Then another is shared database, which is a great approach and you might use it for different solutions, but shared database has this approach that it might grow into one huge monolith. Number 3, remote procedure invocation. In that case, it might be that there is no shared database or there are no files, but you are just calling an API, you are just calling a specific system asking for some data. That system is executing a procedure, and then you are getting data back. And the fourth one is messaging. That instead of having some shared file, FTP or data lake or shared database, then maybe you are using Kafka and you are sharing the messages or just subscribing to those messages produced by the source system. So those are 4 integration approaches that once you are building a solution for data ingestion, you have to think about those 4 approaches. And usually you might use more than one. You are not bound to using just one. So think about history, think about updates. Let's say messaging might get complex over time. So if you are just getting data once a month, so file transfer is great. And just choose what is the best solution for maybe even for each data source. But there are some challenges when it comes to ingestion, and those challenges are following, in my view. That if you have multiple sources, you need to prioritize that. And you will have those discussions, push versus pull strategy. Are data sources pushing data to data lake or to data warehouse, or you are pulling that data? So there are certain advantages, disadvantages that you will need to define. Then, once the data lands inside your data lake, you need to think about indexing and tagging. Basically, you have to know what type of data, what type of sensitivity, privacy, what type of data you have inside data lake. So good practices always have metadata, which is describing what type of data you have inside your data lake. Because once you start just getting files inside your data lake without metadata, without description, who is responsible for that, then it will become just a huge mess. For data validation and cleansing, the good approach is to separate business from processing logic. Use completely different functions for that, because business logic will definitely change over time, and it's easier to keep it separately. And data transformation and compression, try with different compression file types or even databases. There is no one good solution. Just try, depending on your data size, depending how often data is arriving, choose the best alternative. Then there is another approach once you are ingesting data, that you need to apply protection patterns. So one protection pattern says that you are masking some of the sensitive fields before getting that to data lake. So it's called privacy protection at the ingress. As you see in the diagram, maybe you know that some of the columns are sensitive. Let's say column which is coming from your CRM, which is our customer email. So you are saying, well, I don't want that column, that content inside my data lake. Let's just skip that. And in that case, you are not getting that. So it's called privacy protection at the ingress. Privacy protection at the egress means that inside data lake, you have all the data, you have all the sensitive data, but once you are exposing that to consumption, you are hiding that then. So you need to define based on what is your data lake, what is the approach there. So those are 2 approaches that you can use. Let's move to data storage. And once we discuss data storage, I have to mention a few things that have been happening in 2019. And basically, what will happen with Hadoop once the cloud providers are growing, once you have great services in Azure, Amazon, GCP, and they are competing with each other. And there were many articles as, is Hadoop dead? What happens with Hadoop? Is it time to stop using Hadoop for analytics? Well, in my view, I could say that if you think just Hadoop as a storage, then cloud providers definitely provide great storage alternatives. But Hadoop is not everything. On top of that, you have to provide some kind of way for data scientists to build models, for data engineers to build data pipelines. But definitely, cloud providers provide quite cheap offerings instead of Hadoop. And then the question that we come up is, okay, what should I choose, data warehouse or data lake? And on the internet, if you just query this quote inside Google, then you will have those type of tables, comparisons, this versus that. Then here is another table that you could maybe, or here is something else that depending on control, flexibility, but it doesn't answer the basic question, data warehouse versus data lake. When should I use which? So in my view, those companies should use both. But then there are different scenarios. First scenario is, once you know the questions that you would like to ask, it's called top-down. And basically, once you would like to know what happened, what were sales numbers last month, last quarter, last year. So in that case, data warehouse is a great solution for that, where you have data model first. But then on the right, there is another approach, which is called bottoms up, where you don't know the questions you would like to ask. You know that you have the data and you would like to make some hypotheses and validate those. So in that case, you validate and maybe data model will arrive later. And it's for predictive, prescriptive analytics. So in that case, as you see, data warehouse and data lake both can live together happily. Our another box is data preparation and training, which describes what are different tools that data engineers and data scientists could use to explore data and build data pipelines. So one of the main concepts for you to remember is that you should always think about self-service tools. The platform should always enable different tools depending what data scientists would like to use or data engineer would like to use. The platform cannot limit them. Why? Because there always will be a better version, always will appear a new version that you will not wait for months until your cloud provider will release something. He would like just to try maybe better version. How does it work? And in that case, the core concept is build all the solution in the way that you could run multiple different versions. And the best way to achieve that is to use containerized environment, where maybe one model, one data pipeline is using certain versions, another pipeline is using something else. And another important thing that, especially if you are working with cloud data pipelines, in this case, I'm just putting numbers for Azure resources, for Azure storage and Databricks. For storage, you will have that available for 24/7. There is no way to shut it down. But the price, as you see, is not that huge. But then for Databricks, the biggest expense comes out of the clusters, after the computation. And in that case, why should you run that 24/7? Just run it once something is happening, once your data engineers, data scientists are at work. In that case, I'm just putting a number here, 160 hours per month. And in that case, there is a huge cost reduction, which don't forget about that. That's the whole idea with the cloud, just to use on-demand resources. And now we are approaching to deployment and serving. And there is one approach that I would like to share. And in this case, think about the data that you are producing as data products. And that means that think how to model and how to describe a certain domain. It might be in insurance, might be claims, maybe in marketing, that might be your interactions with customers. But think about that and use agree on language and use think of that as one package, and will be unified language. But it could be either transformed or raw data set. It doesn't matter, as long as you are thinking of that as a product that you are giving to others. And in that case, that domain team, and in many cases you are responsible for its life cycle. That means you need to make sure that you have SLAs and you are producing high quality data once you are exposing to others. and you apply metadata on top of that, that you can search for that, you know that it's secure, that you can describe that. And the thing is that each producer, there might be many producers, but the data is an asset that company has, and each department or each system is responsible for sharing its data to organization. And this is the approach that more and more companies are using inside. But if you would like to learn more about how to use data products, I highly encourage you looking at Martin Fowler's blog, and there is great blog post, absolutely amazing, about how to move beyond a monolithic data lake to a distributed data mesh. Take a look, you will not regret it. But if we look overall at data architectures, there are quite a few books that I encourage you to look in. Let's say Building Evolutionary Architectures takes a look at how it's written in the title, how to build architectures that will constantly evolve. And one specific, or the chapter that I liked most is called Fitness Functions. Basically, what's the way to measure effectiveness of your architecture? Another book which I found really interesting is Architectural Patterns, where you will find many great patterns for enterprise, and they are a set of patterns for big data. Guerrilla Analytics, great principles for working with data. This book is targeting, in my view, managers or data scientists, but I think it shows great principles how to build a top-level data analytics departments and solutions. And now, Software Architecture book by Simon Brown. I think this is the best and must-read for all data engineers and all software developers. It shows the value and the importance of architecture and the building blocks that are required in good architecture. And domain-driven design, as I was mentioning about data products, Eric Evans describes how to create domains and how those domains could work with each other in the organization. And now we're approaching our last section, which is principles, best practices, tools. In that case, there's a concept which is called DataOps. And DataOps, in my view, it has those 10 different sections or 10 different components. And let's take a look at each of those. Collaboration means that you need to have tools that enable team, either that's on site in one place or maybe that's distributed, to have calls, to have chat, that might be Slack, that might be Teams. For development, people need to have, or you need to define what type of programming languages they will be working, what type of IDEs will be used across. Maybe someone has his or her favorite one, but usually it's a good thing about putting some standards on top of that. Then for deployment, what are the version controlling system? Do you use Git? Do you use Jenkins? Do you use Azure DevOps to deploy? For orchestration, how do you trigger jobs? How do we provision resources? How do you automate your infrastructure? For testing and monitoring, basically, how do we know that our solution is well tested, and how do we monitor that in production? For data capture, we are focusing on different methods for getting data from data sources. And for data storages, we would like to store that data somewhere, depending either that's historical data in cold storage, or maybe that's data that we would like to use very often, which we'll put on in hot. Then there are different methods to integrate data to have different data validation transformation approaches. Data governance, we based on the needs in Europe, let's say for GDPR or for now new rules in the USA, you need to know what type of data you have, how the data is used, why it's used and the way it's used, what's the purpose, who owns that, the whole data lineage, things like that. And the last but not least, data analytics. What are different tools to build dashboards, machine learning models, etc. So from the context of tools, we see a huge set of icons that you can just pick and choose. If you use, say, Azure or AWS or GCP, then you will have some set of platform as a service offerings. But my idea here is that don't limit yourself. Take a look what other tools are in the market, what are other open source tools, and how they're solving their problems, let's say in the orchestration, what are different approaches for data integration and things like that. So it's always nice to look at different tools and compare and see what are maybe new functionality that they released that would help you. And now we are approaching one of the last principles that I would like to share with you today, and this is my favorite one that I use quite often while building architectures, and it's called last responsible moment. And the idea here is to delay commitments and keep important decisions open. And as you see in the diagram, cost of deciding at the very beginning, it's very high. If you might just choose the wrong tool, and in that case, your decision, the cost of changing that because you chose that very early, will be very expensive. And then the cost of delaying your decision, you see, it increases over time. So what we would like to find, this sweet spot, which is called last responsible moment. This principle originates from lean software development, and it emphasizes holding on, taking important actions. You might ask why this is important and why I'm mentioning this. New versions, new tools are released almost on a daily basis. And if something is not working for you today, maybe there is a roadmap and it will be fixed in upcoming weeks or months. So instead of creating some ugly workarounds, discuss with business, maybe there is some specific functionality that you could delay and now you can focus on something else. And here we approach our end of presentation. I hope you enjoy it. Thank you for joining. And if you have more questions, do not hesitate writing an email to me, connecting on LinkedIn or on Twitter. I really appreciate that you joined me, and to the next time. Bye.